Hi everyone, today we are going to be continuing on with section 9.4, but we're going to start with example 2. And in example 2, we're going to use that process that you learned yesterday, which was completing the square. But our goal for today is going to be to solve quadratic equations using that strategy. So the method of completing the square can be used to solve any quadratic equation. And in order for it to work, it has to be in the form of x squared plus some x term plus bx is equal to a constant d. So in our first example here, we are asked to solve x squared minus 16x equals negative 15 by completing the square. So what we learned yesterday, my first step in completing the square is I'm going to take half of that middle x term. So half of negative 16 is negative 8. And I did that off to the side. And then negative 8 squared is equal to 64. So once I find that constant, I'm going to add 64 to both sides of the equal sign. Since we are now solving equations, you have to do it on both sides to keep the equation in balance. So I'm left with x squared minus 16x plus 64 is equal to 49 because negative 15 plus 64 is equal to 49. My next step is then to factor the perfect square trinomial, which is on the left side of the equal sign. So this is everything that you guys did yesterday. We're going to go ahead and factor that left side, and we're left with the quantity of x minus 8 squared. And then the right side of our equation will stay the same, so that's going to still be equal to 49. And hopefully what you're noticing here is that it becomes a little bit easier for us to solve this equation because we have a perfect square on the left and a perfect square on the right, making it easier to solve this equation. Now, once I have factored that, I'm going to go ahead and solve the equation by taking the square root. So when I take the square root of the left side, I'm left with x minus 8. When I take the square root of 49, I'm left with positive or negative 7. And this was really similar to what you guys did last week in section 9.3. Hopefully you're noticing some of the similarities here. So then my last step here is to add 8 to both sides of the equal sign. And I'm left with I'm left with x is equal to 8 plus 7 or 8 minus 7. And that plus or minus is important. And just as a reminder, the reason it's plus or minus is because when I took the square root of 49, the square root of 49 could be positive 7 or negative 7. So that is an important step there. So my final solution for this quadratic equation is that x is equal to 15 or x is equal to 1. And that is because 8 plus 7 equals 15 and 8 minus 7 is equal to 1. So go ahead and pause the video. Here is number 4 for your monitoring progress practice. Try this problem on your own and then you can check your work with my work provided. So go ahead, it might help for you guys to click pause just to kind of see all of the steps here. I will go ahead and walk you through it. Remember, we wanted to solve this equation by completing the square. So I had to take half of that middle x term, which was negative 1, and then square it, which was 1. So I then added 1 to both sides of the equal sign. From there, I was able to factor the left side of the trinomial into a perfect square. And again, this problem was really nice just because 3 plus 1 equals 4, and 4 is a perfect square. So from there, I was able to take the square root of both sides, and I was left with x minus 1 is equal to positive or negative 2. To solve the equation, I would add 1 to both sides so that the solutions are going to be 1 plus 2 or 1 minus 2. So my final solution for this equation was x is equal to 3 or x is equal to negative 1. All right, there was one more monitoring progress problem. Go ahead and pause this, you guys, and then you can just kind of check in with my work as soon as you get stuck. This one's a little bit more challenging. We're still going to solve it by completing the square, but it's not going to come out to be a perfect square, so you're going to have to approximate your answer. But still give it a try, and then I'll have the answer coming up next. All right, so first, in order to complete the square, I had to add 36 to both sides, and that's because half of 12, that middle term, half of 12 is 6, and 6 squared is 36. So I added 36 to both sides, and I was able to factor the left side as the quantity of m plus 6 squared. And then negative 8 plus 36 is equal to 28. Now, like I said, here is where it becomes a little more tricky because I can't take the square root of 28 and have it be a nice perfect number, but we can still use our calculator to approximate that. So if you continue following my work, I did take the square root of 28 using my calculator, and that gave me approximately 5 and 29 hundredths. And remember, I want it to be a positive and a negative value when I take that square root. Same steps then to solve the equation. I'm going to subtract 6 from both sides so that m is equal to negative 6 plus 5 and 29 hundredths, or negative 6 minus 5 and 29 hundredths. And then my two final solutions, m could be negative 71 hundredths, or m could be negative 11 and 29 hundredths. And notice that my equal sign is squiggly. That's just the symbol to show that it is approximately that value. It is not exactly equal to. So we use that when there's not a perfect square and when you're having to round or approximate answers, like I said.